probability, and this video covers most of the topic here, so it is going to be a bit long. So the first thing, this is the probability continuum. It goes from 0 to 1 and also goes from 0 to 100%. It could be the answers to a probability problem could be a decimal, a fraction, or a percent. And there's 5 different words that we often use. So impossible is a probability of 0, like pigs will fly. And then not likely and likely are zones. This is anything bigger than 0 but less than a half. So a third, a fourth, 3/8, 0.33, okay? And so it's anything less than 50% or 1/2 odds, but not impossible. This is an exact 50% or 1/2 for equally likely, even odds, as likely as not. They use different words for it, but even chances, as likely as not. Likely is another zone, and that's anything that's more than 50% probability, but less than 1. 5, 6, 3/4, 2/3, anything that would fall between 1/2 and 1 on the number line. And certain is something that occurs for sure. So I'm going to switch over to the dot cam, and we're going to look at the topic notes for this. And we would go into a lot more detail in class, but obviously you've been absent or something. And so let's just cut to the chase. So there's that probability continuum again. Remember that unlikely and likely are zones that cover lots of numbers, where these are exact points of impossible being 0, equally likely being 1/2, and certain being 1. So can you have a probability of 120%? No. The percentage 120% works if you had extra credit on a test, but it wouldn't be a probability. The probability continuum goes from 0% to 100%. Give an example of something that will occur. Certain, the sun will rise tomorrow. Impossible, pigs will fly. What would be, what word would describe a probability of 3/8? Well, 3/8 would be right about there. And so that zone is called unlikely. It's a zone rather than these 3, which are exact points. The words are used sometimes, and sometimes they're going to want us to use fractions and decimals. So you will go swimming on a hot summer day. That's likely, but not certain. Okay. There will be children wearing costumes on Halloween. Probably certain. Someplace in the world, kids will be wearing Halloween costumes. Your hair will grow 5 inches in one day. At the present time, that would be impossible. And you flip a coin and it lands on head. Well, that occurs half of the time. So that's that one that's exactly in the middle, as likely as not, even odds. Remember, percents, decimals, and fractions all can be used to represent our probability problems. And so we just have a little bit of review of that. Remember that this right here, you're going to divide by 100. This right here, you read it and then you write it. This is 35 hundredths, so 35 hundredths, and then you reduce it. And then where on the continuum would it lie? This is less than 1/2, but more than 0, so it's unlikely. 7 out of 20, it's unlikely to occur, but could occur. Okay. Starting with a decimal, you would times by 100, write it as you read it, again, unlikely. 3/5, you would take 3 and divide it by 5. That'd be 6/10 or 60%. Okay. We can use probabilities to make predictions. So this says something has a probability of 20% or 0.2, 2/10. And so out of 60 questions, how many would you get right if you just guessed? So 0.2 of the 60, which would be about 12. Okay. I'm going to go ahead and skip that top example. Here, draw a card, then replace it 300 times. The event would be drawing an X. There are 3 X's out of the 5 cards. So this is the probability. And then out of 300 times, we would multiply it out, and that would be about 180. The probability of rolling a 4, well, the probability is 1 out of 6. So 1/6 of 90, which would be 15. So we are going to be looking mostly at experimental probability. So experimental probability is the number of times an event occurs out of the total number of trials. A coin is tossed 10 times and, oops, sorry, I'm over here. The theoretical probability is what is expected to happen. It's the number of favorable outcomes out of the total number of possible outcomes. So there's one side that's ahead out of two sides on a coin. And then this one is experimental. It's how many times the event occurred out of the number of trials. So in this case, there were 7 trials and there were 10 trials and it landed on heads 7 times. So theoretical is what should happen, and this is what actually did happen. So looking at that over here, the relative frequency means the experimental probability. In the experiment, how often did they get a 4? Well, it was 1 times out of 18. But in theory, the theoretical probability, you should get it 1 time out of the 6 sides. This is the number of trials. Here, that bottom number is the number of sides. The experimental probability of rolling an odd. So I looked at the odds and I added those up. Okay, I added up the 3 times that you get a 1, a 3, and a 4. I added those up and I put those out of the total number of trials. Whoops, you couldn't see the chart. I added up the number of times I got a 1, the number of times I got a 3, the number of times I got a 5. In theory, there are 3 numbers out of the 6 sides that are odds. This is the number of sides that are odds. This is the total number of sides. So that'd be a half of the time, which makes sense, right? You're going to roll an odd half of the time. And as you get to a very large number of trials, the experimental and the theoretical probabilities will become almost the same. So as you get bigger number of trials, the fluctuation, the randomness that occurs will kind of start to even out, and you will see that the 2 of these will end up being exactly the same. But as you can see up here in our dice rolling, when only you do is 18 trials, you don't get an even number of both because of just the randomness of chance. We got a lot of 6s and hardly any 4s, but the next time you do this experiment, maybe you'll get a bunch of 4s and hardly any 1s. It'll change a little bit in small trials, but will start to even out as you get huge trials. That's the whole chapter.